All right. All right, and we should be live. Just wait a few minutes for the stream to set up. All right, here we go. So, hello and welcome to this YouTube tutorial for Unity 3D. As always, we'll start with checking over our document, but first I'd like to share a few things. So our current stream times are looking at 6 p.m. Tuesday and Thursday, and 10 a.m. on Saturday for anyone viewing the video who might be interested in dropping by and asking some questions. Please subscribe if you're liking the videos and you're finding the information useful. We'll be adding some more stuff to the channel. Hopefully we have a PC building video and hopefully a 3D video coming up, so we'll be doing some 3D modeling. On top of, I'll be doing some other interesting art type stuff. And today we'll mostly be looking over the basic movement. We'll just be going through our states and filling out certain things in a little more fluid fashion. And we still might not get to wheel rotation quite yet. Wheel rotation will be a very quick thing, but it might just be a bit too much to get through on this session yet. But we'll get more of our states set up. I'm looking to at least get these two fully set, even if this one's only testable. These ones will probably come later, although they have a lot less involved in them. And the grind state is actually like the whole set of performing the grind. So if you've ever played like a Tony Hawk game or Sonic Rider, something where you grind along on a rail, like in skateboarding and such, that's what we'll be looking to make. With that, let's go ahead and jump into the meat of our stream today. And if at any point anyone dropping in has any questions, just let me know. Or if you have questions, feel free to leave them in the comments if you're viewing this after the stream. And I'll see if I can work it into some of the future videos, or if it's better, with just an explanation or answered in a different part of the project. We still won't be doing tracking placement or any of this stuff just yet today, but we will be moving on to our Unity. There we go. So you should be seeing the Unity page here now. And this is where we left off with our project last time. We've organized the player container, containing the player body, containing the parts that were in our prefab. And we have our racer move context right here with our many move states, not the parameters for our many move states. Idle through accelerate. And we have our player input set up and connected. Player input being events and RacerCon standing for racer controller, runtime only, and this calling the move input. Calling from recent move input script. Whoops. Dot move input, which would be All right. Which we should see in our, there it is, our bridge. Inside our bridge, which is doing the racer move input, handling that. So let's go ahead and edit our script, pull that open, and I'll switch over to the code so we can continue our review. So if we look at our code, this is what we worked on last time. We have the move direction, and we have the public virtual move input. So that's the method that's getting called by our player input racer control events. And then this is passing in an input action, and we get the read value from it, and we determine the X move direction and the Y move direction, converting these guys into a vector 3. And because we leave the Y, yes, we move our move direction Y 0, we're not adding any force up or down on the object. If there was a certain mechanic you wanted to do in force using that, you could, but for this is all we're using right now. And public move direction, get return move direction. Okay, and then in our racer move context, we have our systems, collections, racer move context, mono behavior, and we go into our, we should have everything open that we were last working on. Should be using the rigid body and the racer input bridge, and racer move context having the racer input bridge. And on enable, it just gets the reference for the two objects we set up down here. And we set our default state that we start the game on when we hit play, and then private void fixed update. So every time we update, we do the move, or fixed update, which runs about 50 times a frame per default, or 50 times a second for default. And then we have our accessors down here like normal. We made one for the rib and the RB. And then everything should be remaining the same. Okay, so now we have to ask ourselves where we want to start. I would usually start by I would probably want to look at the racer input bridge. So I want to actually change on start, right? But we can't really test that too well, because if we do it on awake, it's not going to be clear what exactly we're telling it to do. It'll just switch right away, and we won't get to see that the method works, because we could have just mistyped the method in, or misset our settings. So I'm going to do a public and overwritable, so virtual void, because we still need to call this outside this class. And what should this be? We'll call this vehicle start, because you could use this for cars or any other thing, not just this robot. So let's do vehicle. Maybe we should do racer start. Let's do racer start, because we might want to use this for a different project, and we want it to reflect the overall function of it, not the specific use of it. And let's copy and paste our parameters up there. So what do we want racer start to do? So racer start, I'm thinking, is something we call when the race begins. So that would probably be called by our game manager, but in this case we kind of need to know where this is at. So we're going to want to go ahead and change the state with this. And right now we can just test it by changing the state. So how do we change the state with this? Input bridge goes to our move context it's going to have to call. And since it doesn't have a current reference to that, we're going to need to create one. So we might need to go in here, and our variable section is pretty small right now, so we'll just create a comment for this. So state change, call ref, saying it's the reference we use to make a state call, but that doesn't really make sense either. Let's just do this. So we'll do something new that hasn't been in the series. We type angle brackets and then serialized field, and then because we want this to be serializable, what else do we want to do? I want to introduce the header. So we have header, parentheses, quotes for string value, and this is going to be the player move context. So anytime we want to make a state change that's changing the movement state based, so we're just using those basic methods that we've already made, I'm going to use a reference I create here, and it's going to just be protected this is racer move state, racer move context, move context. Maybe we should just do, no, we'll leave move context that way. So this is here now, and it's serialized field header. And this is all on the same layer. So we'll show you what this does, and then we'll probably add this to the get of the on enable. So we have our serialized field header. So this will change how this works. And if we save this and head into our Unity, once that finally compiles, we'll head over to Unity, and you can see over here on the racer input bridge, whoops, you have a player move context that has move context. The header tag basically allows us to put this in here so that we can label our sections a little bit better. So if I have a bunch of objects related to move context or move input, that sort of thing, I can put them all under the move context header. Now that you'll realize we don't actually need to assign this because we can just get it from our inspector here, or not from our inspector, but from our object because we're on the same layer. So we do want to go back and change that, and we'll look at going back to the code, and I'll just comment this out. Open up a line in our methods. Protected, on, enable, move context equal is equal to game object dot GameObject.getComponent, and then we're getting a component of type that is RaceRemoveContext with parameters of nothing. What's our an object that is gain RaceRemoveContext? Where is this going then? I see. So this is static. If I want to use this game object, it needs to be lowercase, because this is the reference for the specific instance of game object that this move context is attached to, or rather, this racer input bridge is attached to. And from that game object, we need to use get component. For readability, I'm just going to go ahead and get rid of that for me. Because get component by default automatically refers to the game object that racer input bridge is on, unless we call it from a different object, but we don't need to do that right now. So now that we have our get component, we can move to our racer start, and we can call our move. So get our move context dot, and maybe we called it racer. What did we call it? Racer move context. That's input bridge. So racer start goes to racer move context, and it's dot, and we need to go find the method. Need our change states. So we open that region. Change state, it's done. And we want it to go to accelerate. Basic state of accelerate accelerates at a constant acceleration. So we're going to close that new mono behavior script, and we just want to go back to input bridge, paste that in there, give it no parameters because it doesn't take any. And then this should run our acceleration switch. Now, let's just make a debug.log. So debug.log just logs something to the inspector, and that will be displayed in our console window. The reason we do it this way, because println doesn't actually display in the Unity log, although it would display if you tried to build and run something in here. So debug.log, and we want to log just that we are accelerating. And then change state, debug are accelerating. So we just need to go back to our racer input bridge, make sure everything's running through that. And then I want accelerate. And we should put it in not in accelerate actually, because we start with idle. So we should start in idle, go to accelerate, which we don't overwrite anything in there, huh? All right, let's close all our regions. Look at our regions, state change, and accelerate. There we go. And before it returns, because return ends the process, we want to go to debug dot this doesn't do it either, so we shouldn't do this either, because if we print out here, this isn't where we're actually accelerating. This is just saying that yes, accelerate got called on idle. So erase remove context and accelerate. That should actually work, because in order for everything to be accelerate now, we have to call accelerate on idle. We have to become accelerating and all of that thing. And then our defaults on our erase remove state is to move forward and not in any kind of direction. So let's save everything up. So again, we defined a method, race start. We added a reference to our move context. We got the move context. And then we debug logged when the state, after all of the code has been executed for changing the state. And to make sure, we have a behavior that makes sure that we know in the inspector that this code indeed has run on top of our debug log. So once that's all saved up and compiled, we can move on to our Unity. So move from code to Unity. And in Unity now, we can look at something else. So that's great, we made that method, but how do we call it now? Because we didn't bind a key or anything to it. So let's just go into our input for right now. So if you don't have this racer input, you just have to go back to assets, go into the racer input, double click, and it'll open this for you. Make sure autosave is clicked on, and then we need to go through and add another binding. So add an action. This is going to be start racer. And we are going to add a binding. What's that binding going to be? Let's go with H, something that we definitely won't use for any kind of racing. And then let's go to the, then I guess we can just go down to our game, our input. So this one, start racer, runs H key. And we can go into our scene and over to our inspector. And if we select our object that has the controller on it, or the input on it, we can look under our events, and we just added a new event under Con Racer. So then we add a clickable event, We don't want that window. We drag player bod. We go to input bridge. We do racer start. Everything syncs up nice. You can see we're going to that script down here, getting this method, which will change the start. So then we hit play, and we should see clearly if our thing works in both the console and the editor. So let's go console, so you can see that. And then, so we go left, right, and then if we hit the H key, so why doesn't our HQ do anything? Okay, let's go ahead and turn the code back on. Why doesn't our code do anything? Okay, so input bridge, start racer, goes straight to move context and does accelerate. If you control click, you can follow it straight to where it was declared. So if you're starting from input bridge, control click. I do that a lot just to navigate around quickly. It's a Visual Studio shortcut. So we go looking around the next. And this isn't debugging either. So this probably isn't calling. So every time an action is called in, let's just check. Might be in move state. Because this is defaulted, and then what's an accelerate? Accelerate inherits from move state. Doesn't change anything about movement. So it's not a problem with accelerate. Erase your move state. Let's just take this out of here. Don't need these bools in here. Not going to go back and use those, so you can just take those out. Erase your move context, add force, transform force mode dot force. Okay. Accelerate does not have a move state. Erase your move state has a move method, and this is taking in a erase your move context and adding the force of transform.forward. Here it is. In the last video I took out the multiplier, so this one force of force mode.force is not enough to actually move our player body. So what we actually need to do in here is just like, let's do times 100, and that should fix that problem. However, why is the state not changing? So that we need to check erase remove context, because this is not debugging. So current state is accelerate. First, let's go and make sure it's declared correctly. So bars for state, all of these are instantiated. Yes, they exist. So it's got to be in our accelerate method. And ones. We'll just put this. Let's just do 1. Current.stun.this. So I must have made a typo and forgot to change some of these when I did the mass change. Yup. Okay. So these haven't been fully changed over from when I just copy pasted the methods. So accelerate. So what do we need? So let's finish. Then we'll go back and change those. So this is 2. I'm just debugging numbers so that I know where it breaks. But let's do cur ms. This is dot accelerate. Accelerate. This is changed over. Now y is last. So last is instantiated in the beginning, right? We have stun. We have fixed update. We have on enable. Last, RMS, is not assigned a value at the beginning. So let's assign last, which is probably what this is supposed to be. Last RMS to idle. So this works. Yep. That was probably part of it. Accelerate that. Are accelerating. Okay. So the acceleration should work. We are now checking for the accelerate rate. Let's try this. So we'll switch back over to the Unity. Code off, play on. Once that finishes loading, yep, we'll hit H. And that was indeed the problem. Why it being calling a different state? It still didn't debug though. Any of it. Ah. Ever-ending problem. Okay, so this will clear on start. What happened was I just clicked on one of these things over here and hid the white exclamation marks. And you can tell when we did the one, it runs many times because it's anytime the key goes down, while the key is held, and when the key comes up. Since we didn't specify when that exactly should occur. So we're just going to go ahead and do the... So that's working. I'll go change these while we're still thinking about it. So this is dash. Dash is dash is dash. And then this is accelerate, correct. So dash and accelerator, correct. Yes, I remembered to change all these, but I didn't remember to change the state request. Grind. And what do we have? Idle. stun, which should use stun. So then that all is working correctly. And we can go ahead and comment out our debug statements or delete them. I'll probably just delete them for right now because they're not going to be used again. We were testing something incrementally as we kept expanding it. We'd probably leave those in, but don't really need it. Now that I've done that, I guess I'll share just go back to my code screen. So what are we doing here? We got the start works. It works in a very specific way. So how does accelerate work? Now we might want to tune how accelerate works. And we start kind of building like how is our movement built. So we probably want to rotate it a little bit. What's PlayerBot set up? PlayerBot has 0 transforms, position, rotation, and scale of 1. So you can probably edit its rotation directly. And that's going to be in, so we want to use that move direction, right? So this was our left and right, but the idea of Eraser is to turn the steering wheel and move in a different rotation. So maybe our rotation should be a little bit different. Depends how you're looking to do it. If we're looking to do turn by just rotating him, can do it that way. There's some where it goes straight, and then if you hit over, they turn for a little bit and then straighten back out. Kind of depends what you want. I think we're just going to go for the straight rotation. It'll be simpler to start with, and then we can modify it from there. So let's go ahead and check out accelerate. And accelerate has these state change methods. We're not going to mess with those right now. We're going to look at the public override pool. This is fine. So what we need here is probably a region. And what I want to do in this region is I want to create and edit how the, so edit how character moves. And this is a public class. So anything I wanted to edit in terms of param, I would edit in that SCO we set up earlier. And I'll go ahead and go to coroutines. No. Open a few lines, close the region. End region. And we're going to look at the region. So how does character move? We can do a public override move. So public override void move, racer context, and racer context comes in base.move RMC. I don't want to do what's in the base. Don't want it at all. What we want to do is probably go back to our racer move state. Just copy this line and edit it from here where we go. Control C, accelerate, Control V, and racer move add context transform forward. So we don't necessarily want it transform forward. So what do we want it to be? Be ARMC dot move So move direction. Can't get it, or oh, it's nested under input bridge, so just go get it. Just yeah. Rib, which means it's going to be capital RIB. Rib, and move direction. Okay. So we look at this. Does this work? Well, this is still going to be that left, right, forward. So that's not exactly what we want. Probably want something more towards accelerating in a direction rotated by move directions X. Because this is accelerate, we're thinking this is on the ground or in the air when we're not doing anything particular. So we just want that X input. How do we get X input then? Well, let's just store it in the X of move direction. So we can do, but it's not just the X that we want. So we want the move direction So we want the transform, we want to go forward, edited by how much our right is. So let's put in a couple methods here for us, which we might put into our base class so that the other ones can use them as well. Then we just save some effort. So one should be to rotate body, right? And rotate body should be based. One objective is to rotate the player body. We rotate the player body, not the player container, to leave our rigid body, player container. So player container should remain empty. That's for prefab level. And rigid body is on the player body. And then let's actually add a do that when we go in. So to rotate the player, our current setup is not quite going to work. We'll need to create another child object. But that's fine. Rotate the player. So we'll rotate the player. Then we accelerate. Then accelerate forward. Then we need to do some speed limiting. Up till now, we haven't limited the speed at all. We've just applied force in any direction through input. So we'll start to limit the speed at which we move and at which we can move. So we want to do a move, and this isn't quite going to work. So first, let's rotate the player. Let's do protected. Protected. protected void rotate player. And what do we take in? We're just going to take in a v2. Or we don't have to take in anything. We can either take an eraser move context, like we did for move, and just pass that same context into rotate player, or we can extract the vector 3 in here and give it to this one. So let's go ahead and extract the vector 3. So vector 3 let's do movdir. So we have movdir equals not vector 3.0 rmc dot rib dot move direction. So we're getting our move direction from the move context rib, which is the input bridge dot move direction. And after we do that, we can say this one is going to take in a vector 3. A vector 3, whoops, which is a movdir, no semicolon, and for this we just need to change the body. What we want this to be is not referencing the rigid body, but referencing the transform. And the transform would be on the eraser move context, which would be on the rigid bodies layer. And the player input. So all of these are going to be on the same layer. So what I'm actually going to do is, do I want this? So I want a reference to another object that I'm going to rotate, and that'll represent the visible rotating object. And what do I want that to be? So that needs to be the racer, we can call it racer visible or racer body. And that has to be in the move context or the input bridge. Since I don't really want to put it in the move context, because having the visible body in the move context doesn't make a whole lot of sense. It doesn't make much sense to put it in the racer input bridge either, though. So let's look at racer move context. How many lines is it total? Almost 200. And how many variables does it actually have? Quite a few. And this is supposed to be everything that has to do with the states. And then it also has the rigid body. And it has the eraser input bridge. So actually I'm going to put it here. Eraser bod is equal to, but we can't declare it here. We can't do that. That wouldn't work. We need to go up to the top. And I don't need my vars for creation. I don't need my vars to manage state. Don't need my movement. Well, we could put it in movement variables. This one is not going to be on our same object layer. So we're going to have to either get from children or get from in some other way. So here we will use that serialized field that I showed earlier. I will not necessarily give it a header because that would be more for here. So we'd actually put like a header up here. Header movements bars, just help organize it in the inspector a little bit more. Serialized field of a protected. And then I have to decide, do I want the game object or do I want the transform? Transform has all the rotate properties, and I can get anything else I want from transform too, so I'm just going to move ahead using a transform access. So we have a transform. Then what do I want to do that? That's player bod. Player bod. And player bod is going to be set by something else. And when we set that, we'll do it through the inspector. So let's go ahead and save this. And make sure and accelerate. We're rotating the player, right? So also in Race Remove Context, we need to go down to the bottom, make an accessor for this one. So let's go down to the bottom. And we need to go ahead and access to probably put it in here. Actually, let's do it right where it occurs naturally, up top. Public transform player bod get return player bod. So now we can go to accelerate and accelerate, do player bod. We can access that player bod, so we go rotate player vector 3. So actually this can't be done this way. We need to go and do get this because this will have the reference for us. Passing in that context will give us access to the player bod and the move direction. We'll leave this here in case we need it later. Or if we want to pass it into here. Any rate, racer. So ARMC dot player bod dot rotate. We can put in a vector 3 space relative. We want world, so we're going to not specify a space. We want parentheses. We want line end. We need an amount in a vector 3 to rotate, which should be our move direction, but we're not going to rotate Y, which you can't rotate Y, but it can rotate X and Z. So Z, if I can remember my X is correct. No, we rotate around the Y. And our Y rotation is going to be linked to our X input. Because in a vector 3, it's forward Z, X left right, and Y up down. But when you're applying rotation, it goes around the Y runs. If you think of it as going around a pole, we have Y, and then we go around Y. And our input left and right is going to go around that pole. So we're going to go Y. So let's start with a new. Let's start with this and work backwards. New vector 3. It's going to be. This is going to be too complicated for me to think through. Move direction. Crap. Come on. Let's just copy this. Control C. There gets to be a lot of moving parts when you get too many layers of depth, so we'll keep them flatter. Vector, move direction, and just to keep with convention, we'll go A move direction, and this A mover. So A mover, and then with A mover, I'll be going to do other things here. So new vector 3, A move direction, dot X. It says ZYX, but that doesn't usually apply correctly. So what's our X rotation going to be? I want it to rotate no degrees on the X. So let's go 0. Just put zeros in for placeholder. And I want it to rotate how many degrees on the Y? Well, I want it to rotate, we can do 1. We can do the A move direction, because that passes in a normalized value, so the highest is going to be is 1. And then we're going to do dot, and we said X was our rotation value, so then we have this. So ARMC player bod dot rotate new vector 3 this. So we want to rotate it this much. Should I think even if I just do, yes, I can do that. I can pass in the 3 values manually as well into rotate, which would make it even simpler to read, and then we're not creating a new vector 3. Or we probably are, but we don't have that extra verbiage in there. There's a lot of different overloads for transform, rotate. Interesting. At any rate, so this is our rotation. All we got to do now is call that rotate method. So let's rotate the player. Rotate the player. And we just call the method we made. R-O-T, can't spell. Rotate. P-L-A-Y-E-R, player. parentheses, line end, ARMC with movedir, keeping everything flat. I know this is what I got here when this was called, so we're moving down the line. And we have a rotated player. So now we could add the force, and we can add it in our transform that we can't access this way. So that's where our player body came in. We need a transform direction. So we need the transform of our player body that we put in our race remove context. So let's just grab ARMC and ARMC dot transform dot forward. Let's see if we need the transform keyword. Yes, you do. Technically, that is not its transform. So what this is saying is it goes back to the RMC object that we passed in as reference. It's going in, and from its game object, we're getting the transform that component is attached to. And then we are getting the forward that object is attached to. And since we rotated this, it should be 1 degree to the right if we are turning right. So let's go ahead and multiply this because we haven't set that yet. And we'll get our accelerate param. Accelerate param. I might have named that one poorly. Any rate, accelerate param. So that's our accelerate SCO in our move context. So we go a RMC dot accelerate SCO dot is it max speed? Max speed. No, it's probably acceleration. The amount we want to accelerate every time we run this. Now here's where we run into that. Eventually this will be going much faster if our acceleration is too high. So how do we compensate for this? I'm saying we only want to reach a certain amount of speed. Well, then we don't want to run this if we're at a certain amount of speed. So we can create an if statement. So if the ARMC dot RB, because we can get that rigid body that is stored in the race remove context. If its velocity dot magnitude is greater than, and here we could type a number. It must be less than 29 at all times, but we have like 12 and 16 set in the accelerate methods. So we'll go ahead and pick one of those. It'll be ARMC dot accelerate SCO dot max speed. And we actually want to do the thing if it's less than the accelerate SCO max speed. Then we can create a method, put this inside it. So now, if the velocity is higher than our max speed, or is less than our max speed, so if we haven't hit our max speed, we will add force of an acceleration, move force. And then we always want to limit velocity. So let's go back down to where we did that, speed limiting. So here we want to limit player acceleration. So protected void limit player, don't call it player, don't use player too much. This will change when we change it in the other one. Yeah, don't use rename. Just in case you end up using it for NPCs, you don't want to use player words. So then limit player acceleration, not the catchiest name, but we'll deal with it. I want autocomplete to give me that new line. There we go. So limit acceleration. There was a just in terms of talking about like dumb industry things, there was a time where people were all upset about where this top bracket went. A lot of people said, hey, I want it to be up here, and so your method would look like that. And that was the difference between C# and Unity for a while. One person said, hey, I want it up here, and the other one said, no, we want it on the next line. Doesn't affect it programmatically, but just dumb things when you're looking through different industry code is kind of interesting. That was actually a big thing on preference for a while, and now Unity's code of practice is that it doesn't matter anymore, essentially. So we go limit racer acceleration, add force. So we added the force, now we need to check the force. So we're going to do a very similar thing to like we did with the other one. We need to get our acceleration. So we'll probably need a racer move context for that. So let's just put that as a parameter in there. Do we need the move direction? Not necessarily, because we're just dealing with the velocity. So ARMC dot, what are we adjusting? The rigid body, capital RB dot velocity. And we want the magnitude is what we want to view. And I don't want this to be above a certain number. So what do I want to do? Well, then we'll go if, and that autocomplete's pretty useful. Rigid body velocity is greater than SCO dot acceleration. No, max speed, then I don't want it to accelerate. Oh, we need dot magnitude. So if the rigid body's magnitude is greater, that means how much cumulatively in a direction does it move. Magnitude being just how much it does move. Want to accelerate SCO.max speed. If it exceeds that, we're going to want to limit its velocity, right? So that it never goes above the certain speed. But, no, this isn't actually, no, actually get rid of this. I just want to set a hard cap. The acceleration variability can fluctuate. That's fine with me. I'm not real worried about that. Don't need to be real worried about that in a physics type racer. What we do need to be sure of is just that it doesn't go over 29. So, or in the cap, just whatever cap we want to put in there. So I'm just going to check my other class to make sure I'm not stepping on any toes. Class being whatever parameter SCO there is. So then we don't need to look at enable, don't need to look at that, don't need to look at that region right now. We're just putting in project references. What's that? SCOs. Move state SCO. Does it have a flat requirement? Nope. So like 29 is the minimum. You don't want it going over 29 units per whatever it's calculating. So we just want to go, let's say 25 just to be safe. I usually go 25 as my max speed cap. So this is 10 for the set. So this is like in reference to how fast a whatever state we're editing should be. I want to add another one that's just a, maybe we'll just do it in here to be fast too. We'll do public float. I don't want it to be acceleration speed. I want it to be not max speed. I want it to be world. Yeah, we'll call it world speed. World speed. Reason world speed. This is what I want it to collide with in the world. So the max speed that it can still collide with other objects in a reasonable manner. And it's just going to be get that returns a 25. I'm going to hard code this. You usually won't want to, but this particular thing, there's not too much harm in it. The difference between 25 and 29 isn't that high in terms of what you'll see in the inspector, so I'm not worried about it. Besides, if you don't really want people changing this too often. I suppose if you had one that you really customize the physics engine and stuff, you might want this editable, but if we're not editing how the physics works, how many frames you get in the physics, we're just gonna leave it real dumb here and go down to erase remove context, or not erase remove context. We just want to go back to accelerate, the one we were in. So if, and maybe just walk it back so that we get this back. If the velocity magnitude accelerate.sco dot max speed, maybe we just go here and we get world speed. And then we do our operations in here. So basically what we want to do here is limit under world speed. And no, I'm not talking about like Underworld Evolution frame cut speed, which is quite high at points. Limit velocity Underworld speed. Underworld speed. Speed at which things can actually collide. And then armc.magnitude. Let's create a vector3 copy of this. So vector3 and we'll call this curve L, keeping with some kind of convention. Current velocity is equal to, well, that's not vector3, is it? But we'll just get the velocity itself. So here we get the velocity, and the reason I'm doing it this way is velocity and vector3s are a little different in the way they like to handle things. They don't necessarily like being directly edited all the time. Sometimes it's better to save it in the buffer and then reapply it later, like I'll show you how to do here. And so store current velocity. So here's the current velocity. We're storing it. We want another line of storing something or editing something. So we know our magnitude's too high. We need to slow down our object into the world speed limit. So our world speed limit becomes, in fact, something new. So let's create a new velocity. Let's create a new velocity. And all we need for that is another vector3. Let's go n, but not new, because new is a keyword. So let's go nval. And then that's just equal to, let's say, vector3 dot go 0. Vector3 0. And that's just so I have an empty one, but I don't actually want it completely empty because this is a struct. Vector3 is a struct and not an object, which can cause even more problems to where you can't have it empty. Unity does a pretty good job of handling that, but it still causes a massive amount of problems. So just make sure if you're not going to fill it with numbers right away, use vector3.0, which is a struct of all zeros. So it'd be the same thing as saying vector3 vector3 with parameters of 0 and 0 and 0. That's essentially what you have. And it is actually a new vector when you do it that way. So nval will actually be a new vector because it's a struct. So nval is a struct of equal value to vector3.0, which is a new vector 3, 0, 0, 0. For this reason, vector3s are a little bit harder to wrap your head around when you're first starting Unity and also just programming in general, because structs are not the same as objects. They're similar but not the same. So we need to keep that in mind as we keep moving forward, which again is also some of the problem with assignment, where we were doing where editing the struct directly can cause issues. So now that we have a new velocity and a RB velocity, let's go ahead and set, because we don't want to edit the y, correct? Because that's our falling speed. If we want to edit that, we should edit how gravity affects it, or its mass, or something else, and not edit its velocity directly, because that'll change our input problems. It'll affect our input, because we don't want to be doing that directly all the time. What we can do also is just do the really simple one, where we just normalize this. And so this just returns everything in terms of 1. So if you had 1, 1, it would return like a 0.5 and a 0.5. So it would split the difference or change it that way. So we can either do this, where we normalize it and then we multiply it by the world speed. I don't really like that approach. What I prefer is just to clamp everything, but that's kind of expensive as well. To just normalize it and multiply it is pretty inexpensive. But actually we don't want to do this in this line either, because these are structs and that has caused problems for me in the past. So you can clamp how fast you're moving x and z, or you can and let the y be taken care of by other factors, or you can change the 0 and multiply this normalized. So current velocity dot normalized. I'm going to do that just because it's simple for right now, and I'm not sure the clamp. I'm not sure this is the type of game where the clamp will enhance how the game works. Seems like it might make things more complicated than it needs to be. Wait, no. Yeah, I'm gonna do clamp. I just like how much more accurate it is. So this is the velocity, vector 3, 0. Let's do n vel dot x. So we're going to be setting the x value directly as equal to curvel dot x. And that's not all of it. We're actually going to use some math. Math f dot. Why isn't this highlighting correctly? Something weird. There we go. Math f. Okay. Lowercase f dot. And you got a bunch of functions in here that are just common, useful math functions. There's clamp. There's also delta angle, which gets the angle between two numbers. So say I have a 90-degree angle and a 45-degree angle. Or what was this one? Float current, float target. So shortest distance between two angles. So if I type in 145 and 0, it'll go counterclockwise instead of clockwise, and I don't have to do all that math. floor rounds to the floor, and seal is somewhere in here. Yeah, rounds to the top. So seal, floor, those are pretty good. We're going to be using clamp for this. Clamp. And you notice me flounder back and forth on that decision for a little bit, and that's just because I don't. So if you, I'll re-explain the efficiency, or not the efficiency, but the accuracy later here. But clamp, so I need curval x. So I'm clamping between 0 and, if I remember, is this inclusive? Min, the minimum floating point values compare against. Clamps given value, given some values returns the given value if the minimum maximum range. Okay, so these are inclusive, so we can just do 0, and I want the I want this one, because we're going to access this directly. Dot acceleration SCO dot world speed. And then we end the line. So what this is saying is I'm saying the new velocity dot x value equal to the clamped value that is somewhere between 0 and accelerate dot world speed. And that value that I'm clamping is the current velocity x. So the x value could not be above 25. If you had certain problems, this wouldn't work with, but for this one, we're going to use this, and it should work just fine. I'm also going to do this for the y, just because if you're falling, we don't want you to exceed a certain speed and clip through the world. And we just do this for all three. Yes, and to be more clear, the reason I didn't normalize and then multiply by world speed is you can affect the how it looks for your acceleration. So if I'm moving x, y, and z, I want to limit them to 25. I don't want to limit all movement to 25. I just want to limit each direction to 25. And that's why I used it that way. Because then we'll also check if our gravity is above our world speed, and we'll limit that, while not, and we'll never change the y, but it'll keep safe, within safe boundaries. Shouldn't have saved that just yet. Now it's compiling. So we have world speed. So now that limit acceleration takes in this thing and runs, now we just go back and we're going to call it. So we rotate our racer, we add the force in a direction if we're within certain bounds, and we, oops, we're going to, I'm just going to go copy the method name so I don't misspell it any more than it already is misspelled. And parameters of line end, and it's going to be this ARMC. And that RMC gets us to that. We could move this into something called accelerate player, which would be a good idea, or accelerate racer. which I might do just for ease of readability. And we might also want to use that later. CC ELERATE accelerate eraser. This will be void. And I'll just do this. And everything that's red we have to change. So ARMC is just the fact that we don't have that reference passed in here. So let's go ahead and grab that as a requirement. Then, just to be safe, we're just going to block comment this for the time being. And then ARMC. And we're going to add a line, and then add a line. So we rotate the player, we'd accelerate the player. And let's not call them player, let's call them racer. And then we limit the racer. So and this is how I usually think of most actions. I think of it as direction, force and speed, world restrictions. So anytime you're thinking about movement, you want to keep those things in mind. Where do I want to look? Where do I want to move to? Slash how. Like, yeah, any easing or anything that has to be done beforehand. At what speed? And then just keeping it in line with the rest of the world. Um, 7:30. I'll probably test this stuff and then I'll move this over at the beginning. We'll just do some upkeep as part of the review. Moving this into the racer move state. Yeah, we'll set this up as part of the default and edit some of that stuff. So let's see, we have our acceleration, which should all work, should all be connected, should move at a speed. So and we know it connects correctly in the input so that our state does change. So let's head back over to the Unity and do some quick testing. Turn code off and onto the platform we go. Oh, accelerate isn't quite saved, so we gotta wait for it to compile quick. Just a little compile. Just a little compile. And with this little compile, now we'll be able to go test some stuff. We didn't put any debug log statements in here, but we're not jumping across scripts. We're just seeing that the behavior is correct. There's not really all that much that can be different. What I want to do is go ahead and make sure this plane is bigger. So I'm going to just lock the scale. Oh, no, not lock scale. I guess just drag. Nope, wrong way. Let's do 100 by 100 just for fun. So 100x, 100y, or 100z, I mean. So then we play it. Okay. Okay, so this isn't our idle, our test connection to get direction. So then if we hit H, whoop, what? Unassigned reference exception. Alright, yeah, that's right. We had setup we didn't quite do in here. So player bod needs a, and player move context needs that player bod reference. So what I'm going to do here is just create another empty. Create an empty. And we'll call it bod for right now because I don't have a better name for it. And we'll just throw some everything. We'll just throw some everything in there. So all the parts of the robot. Quick way to check that I have only like all the body pieces. I just turn this on and off so it affects if it's active or inactive, which will help you locate some things once in a while. Make sure everything's nested correctly. If you can't tell from looking at this, bod, and then player bod, and then transform, bod's transform. You can either, I would just drag it in from inspector, so you have player bod inspector open, you see that, then just go grab bod and pull it in to that connection there. This isn't all that helpful. I mean, we've got a small scene, so it's kind of helpful right now, but if we were to have a larger scene, this would be something we'd have to just sort through, which we don't want to do. It's always best to just, if you can, drag it in or use some kind of setup where you have the shortest list of things to choose from. Okay. So let's try it now. And then if we hit H, it should debug, and we should be able to turn one way or the other. Ooh, what happened? Did I not connect something correctly? He has the movement. So he's moving in a direction. So he's moving. Okay. One problem is that the accelerate racer add force accesses this armc.transform.forward. So that's not correct. That needs to be the player bod. We should rename that to player bod.forward. Alright. Then let's see what our behavior is. After a quick compile, scene, player bod, Something's adding force in a negative way. But why would it be in a negative way? Let's check which direction our forward's going. Ouch. Ah, because our transform forward's negative. Okay. Probably could have looked at that. And then this one's also negative, which in testing, when we just were testing the four directionals, we were just looking at, is it moving the correct way in world space? We weren't paying attention to, is this moving forward? So, that's interesting. So what are my options? I can rotate this, but that's not really what I want to do. I can rotate these. Okay, so if I go through every object, rotate them on the Y, 180 degrees. That's not quite it. So if I can't do that well, what would I do? My next step would be to make it flip by itself somehow. Well, if I flip, as I'm applying the rigid body up here, and it's inverse of rigid, no, it's inverse of transform is wrong. Then bod. So what I think is the only quick solution is to make one here called bod flip. This is the only fix I can think of right away. Is that we apply bod flip, and then we put all these guys in here. That way, this guy's rotation is still correct. Bod transform in relation to the rigid body, but we can right hand, left hand cramps. We can flip this guy using rotation around the Y of 180. So now we have him facing the right way. This is editable in a normal way, so it's still in world terms mostly. And this is still unrotated. Let's try playing that. Then H. Oh, looks like it's working. Then we use the arrow keys and we can turn a little bit. Gives us control. Gives us that sort of thing. So now we have a turning robot at speed. And maybe we'll add, maybe one thing to do would be to go in and add some parameters so that we can change how fast he turns, make a turn speed. And we'll need to go rename that one function. And we'll need to go do some overall just cleanup before we get too excited on editing more code. But we have a moving turning robot, even though our wheels don't turn. And we'll actually look at changing how these wheels, not the colliders on them just yet, but we'll look at changing how the rotation of this would work. All right. So that'll be mostly it for today. See if I can pull that up. Yep. So a document, where are we at so far? We have our states, we have idle through accelerate through stun. We've implemented, well, we'll change idle to be just sitting, which is just overwriting that one code. People can probably do that without watching anything at this point. Change it so that idle just sits there, doesn't move. We have accelerate. So accelerate is moving and rotating. Great. Then we have dash. So we want dash to do a dash. We'll fix that later, or work on that later. We have drift. We have grind, and we have stun. So out of the ones we have left, we'd probably want to look at one of these two next time. That would be Thursday at 6. And we'd likely start to increase our turning. We'd increase our turning and drift, and we'd increase our and maybe lower our acceleration. And then dash, we'd have probably just an increased acceleration time, like increased max speed, very high acceleration, and then we'll look more at these after those two get finished. And wheel rotation will come sometime in the middle, possibly pretty soon since we've gotten the accelerate method mostly or accelerate state mostly taken care of. We got so with that, I think that's where we'll leave it tonight. So again, stream times are 6 p.m. Tuesday and Thursday, and then 10 a.m. on Saturday. These are CST, Central Standard Time, US. And if you're finding the videos helpful, please subscribe. And if you're interested and want to ask questions live, don't forget that those times are posted there. And they'll looking for some way to post them on my channel as well. So with that, thank you, and you have a good night.